Hello everyone. So today in this video we are going to solve a question of bi-weekly contest 148, which is a medium level question. So the question is minimum cost to make arrays identical. You are given two integer arrays ARR and BRR of length n and an integer key. You can perform the following operation on ARR any number of times. The first operation is split ARR into any number of contiguous subarrays and rearrange these subarrays in any order. This operation has fixed cost key. So the first thing is we can rearrange array. Okay, and the value will be plus k. Then the second thing is we will not without rearranging. Okay, without rearranging we will just add the value x to it or subtract to me. Okay, we can add, let's say, plus x or minus x. For what? To make our ARR equal to BRR. Okay, so if we are not rearranging this second thing, and what we have to return is minimum total cost to make ARR equal to BRR. So the question is we have to make ARR equal to BRR, and two things we can do to make this ARR, okay, to equal BRR. Is first thing is we can rearrange the array, and then let's say this operation has fixed cost k. So rearrange the array which has plus k. Okay, we will fix cost plus we will do this thing is how much, plus x or minus x. That means plus k we have to do for the operation of rearranging the elements. But after rearranging there is a possibility, right, ki both will not be the same thing. We have to add some or subtract something. So we have to add plus x or minus x into it. And the second thing is without rearranging we can just check both the elements. And let's say minus 7, what is the difference to make this is again 7. We have to take the absolute value. Okay, uh, so we have to take the absolute value. As I say, why I'm saying absolute value, because we can do what, x. So we can subtract, add or subtract. Okay, so if I'm subtracting, then or adding, then we are like we can take directly the absolute value, absolute difference, so that if we can add or subtract, right, both are there. So if we want a negative number, we will just add it. If we want a positive number, we will subtract it. So the first thing is without rearranging, we can just check this and this. We will find the absolute difference of this. Okay, minus 7 will be minus 14. So the difference is 14. So let's see this example. Okay, with what? With first is without rearranging, directly checking. So minus 7 plus 7 will be 14. Plus 9 minus 2 will be 11. 5 minus 5 will be 10. So what is total is 14 plus 11 is 25 plus 10 is 35. So total 35 is the cost without rearranging if we add. So what we are adding, 14 we are adding into minus 7 to make it as a 7. We are adding 11 to 9. Okay, we are subtracting 11 from 9, we are getting minus 2 as we are checking the absolute value, right? And 5, okay, we are subtracting 10 from 5. We will get minus 5. So in this way 35. Why we are not writing here minus is we can subtract or add, right? So here in this two case we are subtracting, but by we have to find the total cost, and it will be positive. We are considering this. Here you can see the cost of operation is x, either it is add or subtract. Okay, this is now what is there. Second thing is rearrange the array. Rearrange means which will be the optimal one. If we sort both the array and find the difference, that will be better. Okay, find the difference means for this thing. Now right now without rearranging we are finding the difference, and now for rearrange we will sort this array to two arrays, that is minus 7, 5 and 9. and the BRR will be -5, -2 and 7. Okay, so what is the difference of -7 and -2? -7 and -7 and -5 will be -7 plus 5, that is 2, plus 5 minus -2 is 7, plus 9 minus 7 is 2. Now this is what 7, 8, 9, 10, 11. But as we are rearranging, we have to do the plus k. What is the k given here? 2. So plus 2 will be 13. So this is 35 and this is 13. So which is the minimum? 13. So the answer is 13. You can see. Here in this case, 2 and 2 and both are same. So no operations are needed. So let's solve. Let's code this question. Let's code. Okay, first let's say I will store in someone is equal to 0. Okay, so let's do this first thing and then we will sort both the arrays and then again we will do this thing. Okay, so for int I equal to 0, I less than, we will take one int n is equal to arr dot length n I plus plus and someone plus equal to math dot absolute value of what? Arr of I minus brr of I. Now we will sort arrays dot sort arr and arrays dot sort brr. Now we will do the same thing again and we'll calculate sum 2. Int sum 2 is equal to 0. Here sum 2, same thing. Okay, now what we have to return? Math dot minimum of sum 1 comma sum 2 plus k. Why plus k? As we are rearranging, we have to do plus k. Here you can see fixed cost plus k. Let's run this code. Accepted. Let's submit this. Okay, wrong answer. Okay, our output is wrong. Let's take long instead. Yeah, now submit. Yeah, you can see our solution got accepted. And in this way we can solve this question using a simple approach, that as we have seen there are two conditions. So either we have to without rearranging, we can do the plus x minus x, which we can find it using the finding the difference, absolute difference. The second is rearranging. So the optimal one will be rearranging, will be the after sorting only. Okay, so then only we can find the minimal difference. Higher value and higher value will be the minimum difference. And so that is why we will be doing this sorting and then again we are finding the absolute value. At the end we are doing sum 1 and sum 2 plus k. Why sum 2? Is because we are doing this second thing in the first also, right? So this second is we rearrange the array is plus k plus what is the difference which we get. That difference means we have to add x minus x. So we are taking absolute difference for that. Okay. Thank you so much for watching this video. If you feel this video is helpful to you, please like this video and subscribe my channel. Stay updated.